This is video lesson 2.7 for Foundations in Pre-Cal 10. This is part 1 of that lesson, and we're starting on page 207. This lesson is more problem solving, but specifically it's problem solving using two right triangles. And that means that you're having to find the information from one in order to solve the other. So there's a couple of ways, a couple of situations where this comes up. One is problems in two dimensions. That's a really common one. Sorry, yeah, and then it's problems in three dimensions. That's where it's more interesting. Okay, I just want to highlight in here, again, only the final solution should be rounded. That's always the rule. And these things are not to scale. You can't assume they're to scale, all right? All right, so in the diagram given, QS equals 32, so I'm going to write that down here, 32 millimeters. An angle PQS, that means it starts at P, it goes to Q, it goes to S, is 50 degrees, so that's 50 degrees. And RPS is 61 degrees. And this one down here is, of course, 90, as is this one. And we are going to figure out the length of QR. QR. Okay, so that's that one. It's the whole thing. So since QR is not part of a right triangle, I'm pretty darn sure that I'm not going to figure out QR in one bit. What I'm going to do is find Q or RS and add that to SQ, and that together will be QR. So I'm going to come over here and I'm going to set my question up, or my solution up. I'm going to go QR equals RS plus SQ. So that means it's going to be something that I don't know yet, plus 32. And then I'm going to add them together, and that's going to be in millimeters. And then I will be finished. So in order for me to find RS, there's two ways that I can do this. And it actually doesn't matter which order I do this in, how my thinking goes. But let's pretend that let's start from the end. Okay, so I'm looking for RS. Now, to find RS, I need to know some things about this triangle. I only know two things about this triangle. I only know the 61 degrees and the 90 degrees. I don't know any side lengths. So which side length am I likely to be able to find? Well, I'm not likely to find PR because there's nothing next to it. I'm much more likely to find this one. So I'm going to give that a D for distance. And so what I'm often looking for is look for the common side. And by that I mean the side that is in more than one triangle. Okay, so that's that D right there. That's the connector. So if I come over here and I write RS is my colon. And I'm going to call it, actually I'm going to call it RS. I'm going to label that one X. I'm going to call that X right there. So to find X, if I know that angle, I'm looking at tan. So tan theta is opposite over adjacent. So tan 61 is going to be X over D. But I don't actually know what D is right now. So I have to wander off and find D. So I'm going to come down here and find D. So D, I'm looking at the other triangle now, and it's going to be tan again. So tan theta is opposite over adjacent. This time it's going to be tan of 50 is going to be D over 32. So D equals 32 tan 50. So D equals 38.1361146. And I'm going to take that value of D and I'm going to bring it up here. So that now I have tan 61. Oh, sorry, I can actually solve this for X. I should have done that before. So x is going to be d tan 61. And I'm going to bring this value of d and plug it in here. And I'm not even going to bother writing it out because I'm going to use all of those digits. So it's going to be 68, 68.7993725.9, and then that's my x value, which equals RS. So that's going to come over here, and I'm going to put that into the nearest millimeter. That's going to be 69. And so if I add those together, I get 101 millimeters. Okay, 101 millimeters. If you are just copying this down, I really encourage you to take a separate piece of paper and just work through this to make sure that you see what's going on. Okay, that's really important that you work through the problems yourself and not just copy them down. All right, one more here. Calculate the angle of BEC. So BEC, so here's my theta that I'm looking for to the nearest degree. And so the triangle that that's part of, I don't have enough information on, so I need to find the common side. So I'm going to call that one, I'm going to call that x this time. That is actually an x, believe it or not. So first I'm going to calculate my x. So to calculate my x, if I look at this triangle, it's opposite over hypotenuse. So I've got sine theta is opposite over hypotenuse. So sine 39 is x over 3.7. So x equals 3.7 sine 39. So x equals 2.32848547. And I just write it all down because it's easier than ever having to calculate it again if I lose it out of my calculator. And then I'm going to look for theta. So looking at the BEC triangle, I now have, if this is my angle of interest, I've got my adjacent and my hypotenuse. So I'm looking at cosine. Cos theta is adjacent over hypotenuse. So cos theta is x over 4.6 equals 2.3 over 4.6. And I get theta equals 59.589 to the nearest degree. Theta equals 60 degrees. So the best answer is angle BEC equals 60 degrees. And there we go. All right, and now we've got a contextual problem in 2 dimensions. So, all right, in January 2003, the tallest building in Rockyville was the Metro building. Recently, a developer was commissioned by the Gamma Pro Oil Company to build a taller building next to it. From the top of the Metro building, the angle of elevation to the top of the Gamma Pro building is 24 degrees. So that's this one. That's 24 degrees. There we go. That's 24 degrees. Angle of elevation. And the angle of depression to the foot of the Gamma Pro building is 56 degrees. Now remember, the angle of depression is the one between the horizontal and going down. So this is 56 degrees. All right. It's not this one. It's never the one between the vertical and something. It's always between the horizontal. Okay. But we also know that the other side of the Z, well, it's kind of a backward Z, but this angle down here is also going to be 56 degrees. So I'm just going to write that one in there right now. That might be handy. If the buildings are 45 meters apart, so we got 45 meters, determine the height of each building to the nearest meter. So we need the height of the Metro, and I've got a triangle. This is a 90-degree angle, so I'm going to be able to find that one directly. So I'm just going to leave a space for that one. And the gamma pro, that is going to be the height of the metro plus another height. So it's going to be the height of the metro plus something. So that's going to be something plus something, and that's going to equal something, and then I'm going to round it in meters. All right, so there's all my blanks that I need to fill in. All right, well, let's first find the height of the Metro Pro building. So HM, height of the Metro building. Or the Metro building, not Metro Pro. Okay, height of the Metro. So I've got, let's label it here. This is HM. So if I look at this triangle, there's my angle of interest, opposite and adjacent, it's tan, so tan theta, opposite over adjacent. Tan of 56 is going to be the height of the metro over 45, so the height of the metro is 45 tan 56, which is 66.71524. So I can come up here, I can round this one because I'm going to the nearest meter. Okay, and so I can round this one. This is going to be 67 meters. So there's one of my answers. But when I write it in here, I'm not going to round it because I'm going to need more decimals, and I'm going to write in 66.71524. Now, rule of thumb is always keep at least 2 digits past what you're rounding to. So the very minimum that you would put in here is 66.715. More decimals is always better. Okay. And now I need to figure out, I need to find D. So I'm looking at this smaller triangle. Remember, this distance here is also 45, right? Because we're assuming the buildings are both perpendicular to the ground and parallel to each other. Otherwise, the city starts falling over. So to find D, it's again going to be tan theta is opposite over adjacent. So tan 24 degrees is going to be B over 45. So D equals 45 times tan 24, which is 20.035 something something. So I'm going to write this up here. Oh, that was supposed to be not a blank. That was supposed to be plus D. Sorry. This is where I'm going to write the value for D, 20.035. Oops, lost my decimal. Now I can add those, but don't round, okay? Don't round these ones. Do not, where am I going to write that? Do not round yet, okay? And it's a little bit more involved this time because you've got more than one number that you need to keep. So you can't just use the one that was in the calculator. So you do need to write down some more digits. Anyway, if I add those together, I get 86.75, which I'm then going to round to 87 meters, and there's my second answer. Oh, that was a long lesson, those are long examples. They do take a while to work through. There's a lot going on in these questions. Okay, go and do questions 1 to 6, and then come back and watch the last video for the trigonometry unit.